Hello, everyone. Welcome to today's webinar titled Level Desired, Flat Required. I'm Jim Olson with the National Tile Contractors Association, and I want to welcome you and thank you for taking time out of your busy schedule to attend today's webinar sponsored by Merkrete. Before I introduce today's speaker, I want to remind you that during the webinar, you will be muted. Please use the questions area on your computer to type in your questions, and we will answer those questions at the end of this presentation. If the audio on your computer is poor, call the number on the invite to this webinar and listen on your phone. All NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented. This should give you easy access to watch and or share all current and past programs at your convenience. And I want you to know there are hundreds of programs on our YouTube channel. Please go to the NTCA website and click on the YouTube button at the top and you'll be directed right to it. All right, I'm very excited to introduce today's speaker, Brett Mauney. He is a CTC, CTI, and is Merkrete's National Technical Manager overseeing the company's extensive technical training. Mauney's career stretches back to 1988, working all sides of the tile industry to include ceramic tile and setting materials manufacturing, installation, sales, and distribution. Since 2007, he has provided comprehensive technical support for Merkrete's renowned tile setting materials. I welcome you, Brett, and I look forward to a great presentation.
Thank you, Jim. Well, thank you everybody for being here today. And as Jim said, I'm Brett Mauney with Merkrete Systems, and he kind of went over my background here. You know, the bullet points there, it kind of shows a little over 15 years with Merkrete, second generation of the tile professional. My father was a commercial tile contractor on the West Coast. I am based out of Chicago now, spent 26 years on the West Coast. So, you know, I had a lot to learn when I moved out to the Midwest about 9 years ago. But as Jim stated there, I'm a CTI and CTC graduate, and then on the very bottom there is my email address. So if anybody in the future regarding the presentation or with anything really, there's my email. You're more than welcome to write it down and send me a message or send me a question, whatever it may be in the future. But we're going to go ahead and get started, guys. As Jim stated, we're going to talk about level desired, flat required. And it's really understanding the complications that arise from suboptimal substrates, and also talk about TCNA's requirements that prevent them. You know, you're going to hear me through this presentation talk about TCNA, the reference manuals from TCNA, basically all the alphabet soups. I've got some methods and some things that we're going to talk about, but we're going to go through this, and really I wrote this presentation and taking everything that I've learned over my 30 some odd years in the industry, on working all sides of the business, as well as being on the manufacturing side, installation side as well. So, you know, with this and the objectives that we're going to try to get through today are understanding the fundamental concepts of proper substrate preparation and material use. So, you know, we've got what type of substrates we're going to discuss and what type of products would be best suited for those. Review appropriate substrates and product categories, review key considerations for each. So we're going to, you know, I've got some methods on here from the TCNA handbook. Some of them are more the difficult methods that we don't come across every day, but they're really good examples of showing what the TCNA handbook's looking for when it comes to flat or level. And so we'll discuss those and go through those. Understanding how to incorporate these products into your job for successful tile installations. And that's really, you know, again, kind of with those methods, is how are we going to incorporate a self-leveler or a patching compound, or when do we want to use a mud bed? So we'll go through that. And the last thing here, which we're going to kind of, you know, this last bullet point really hit throughout the entire presentation, and that is why flat can be better than level. We use the terminology a lot of time, I need a level floor. Well, sometimes level may not be that true application. Just to throw out an example there, if you're doing an exterior application of tile on a floor, or, you know, exterior floor substrate, is typically we want it pitched. We want water evacuation. We want that water to be able to go somewhere other than puddling or sitting in the middle of that. So we want it flat, but not necessarily level. So let's get going through the meat of this. And we're going to start with some pretty simple concepts here. And I know there are a lot more, but you can only put so much into a presentation. But really the question is what is a substrate considered in the tile industry? And a substrate is the underlying subsurface that tile will be installed on. So this could be walls, it could be floors, ceilings, some guys call exterior walls, facades. It just depends wherever that tile is going. You have a substrate that you're putting it on. You're not installing it to air. So with those substrates, there's more categories in this, but your basic categories that we're seeing on a daily basis are walls. And those walls could be, cement backer units. So if you see a CBU on there, that means cement backer unit, EGP, exterior grade plywood, concrete block, and even an interior drywall. These are all acceptable substrates that we could see for wall applications. And when you look at floors, could be concrete, could be OSB, exterior grade plywood, or even gypcrete. Again, these are acceptable applications for floors. Ceilings could be made up of CBU, exterior grade plywood, concrete block. You kind of see the whole thing there, that when you look at acceptable substrates, they kind of repeat, but it is still a substrate. It just depends where it is. On a lot of these floors and walls, heck, sometimes even on the ceiling, you might have a mud bed, and that's going to be in that concrete category. So we'll hit these, we'll talk about them as we go through this. And again, if you all have any questions, send them over through the chat. We'll get to the questions at the end when we're finished with this. So let's move on. So here's one of the most important things that sometimes gets confused by who is responsible for this. And that is the ANSI 108.1. ANSI designation. This is the general requirements for subsurface and preparations by other trades. Now, this is, pages and pages within the ANSI book, but when you look at the excerpt from 2.4, your backing surfaces, these can be horizontal, vertical building surfaces by one or more methods described in these documents. And so we're not going to read through that. But really what it's hitting on is that this floor or substrate needs to be clean, structurally sound, and solidly bonded, free of bond breakers, flat and smooth. Notice it doesn't say level in there. And then it says free of excess movement. So, when we talk about or incorporate ANSI 108.1 into our installations, sometimes that might be the general contractor. This is what he's supposed to leave you with. Now, I think when I just said that, if this was live, not live, but if we had the microphones on, I could probably hear a bunch of people giggling or saying some words that may not be appropriate. But this is what the GC is supposed to leave us with, or the person, whether it be the drywallers, the concrete, people pouring the concrete, whatever's left. Not necessarily all the time are we left with the best substrates. So in turn, we as the installer have to come back and look at this with that same ANSI designation and say, okay, is that floor, did they give us a clean, structurally sound and solidly bonded floor? Is it free of bond breakers? And bond breakers are going to be, could be drywall dust, could be overspray from paint, could be, just dust. A lot of people don't realize it, but our biggest contaminant in the industry, our biggest bond breaker is dust. And, there's ways that the TCNA as well as the TCNA talk about how to remove that dust and make that floor acceptable for ceramic tile. And then free of excess movement. So this is a really simple slide. I've been using this one for years. And, really when we're working with this slide or looking at this slide, we've got flat. If you define flat, it's plain and smooth with no curved or high or hollow parts. So if you look at that first one going across there, that's flat and level. And if you look at the one below it, that's flat, but it's pitched to one side. And then of course we got a vertical one over there going flat on that. So, sometimes level is desired, but more than likely we're looking for flatness. And again, it all depends on that installation that we're doing. Exterior, it's going to be pitched. If it's a shower pan, we're still looking for flat, but it's going to be pitched to drain, so that way we can't evacuate that water. But yet when we are doing a vertical surface, we want flat and plumb. Plumb and level, we're going to kind of call them the same thing, but flat and plumb to me are the same thing. But again, flat and level, when we're starting to look at these substrates, we really want to take into consideration of what are we trying to achieve for that installation. So when we're looking at this, and I'm gonna read this paragraph word for word because this is such an important paragraph, and we've got two of these slides are gonna be very similar. But when we're talking about this, this is directly out of the TCNA handbook, but it's also with a lot of the methods that that you're seeing within there. They might be in the by other trades, or it might be under requirements or suggestions. So there's different areas that you might find this, but this is for standard size tile. For tiles with all edges shorter than 15 inches, maximum allowable variation is 1/4 and 10 from required plane, with no more than 1/16 inch variation in 12 inches when measured from high points in the surface. I wanted to read that whole paragraph because it's critical. It hits on a lot of things. But if you look at my little diagram there, you see a flat floor with a little undulation in it, what I always refer to as a bird bath. And we've got, let's say it is that 1/4 inch, depth that it drops off from that 10-foot straight edge. That's an area that is concerned that we now need to address. Now, if you look at that little picture on the right-hand side, it's a little difficult to see, but that's a 10-foot straight edge on that floor. And you can see from that gap as it goes from the right hand of that picture all the way to the left side of it where that straight edge ends, that gap's getting bigger and bigger and bigger. And these are things that we're checking on those floors, so we can meet the ANSI 108.1 designation, but also two, so that way we know what we're working with and we know what we need to do, and then choose the appropriate products to get that floor to meet the tolerances required by the TCNA handbook. So again, this particular one is for those, I'm going to call them standard size tiles. So anything that's under 15 inches with one-sided. Now, when we look at this, this includes 15 inches in length or longer. So again, I'm going to read this paragraph. For tiles with at least 1 inch, 15 inches in length or longer, maximum allowable variation is 1/8 inch in 10 from the required plane, with no more than a 16th variation in 24 when measured from high points in the surface. You notice the tile gets bigger, the stringents, the requirements get smaller. So now we're looking at an 1/8 inch variation. If you look at that level in that bottom right-hand picture, you can see, I mean, I can see plainly that that's a lot bigger than an 1/8 inch variation, what's going to be happening in that floor. So as you can see with this, in this designation, that 1/8 and 10 is for those tiles 15 inches in length or longer. That could be a 6 inch by 36 inch plank tile. I'd probably say, and I think I'm correct on this, that the 12 by 24 tiles are probably the average size tile being installed nowadays. When I started in the industry, floor tiles were 8 by 8. If anybody ever used a 12 by 12, I was thinking, man, this guy's got to be rich. That's a huge tile. Tells you how long I've been around, but 12 by 12 has gone the way of the dodo bird. So when you're looking at these tolerances and what we need to achieve in these floors, the question always leads to, well, how am I going to fix this? How am I going to make that floor acceptable? Let's say, for example, if I'm doing a thin gauge porcelain panel on a floor, is you're now looking at a situation where, of course, it's going to be a large tile over that 15 inches. That floor, in some cases, the manufacturer of that thin gauge porcelain panel might even require an even more stringent. But these are the TCNA recommendations for that, or requirements, really not a recommendation, but it is a requirement that these floors meet these tolerances. And it kind of gives you an idea of how important these are. So what are the effects that do not meet tolerances? These are some fantastic pictures that have been compiled here. When we look at the bullet points on this slide, we're looking at lippage, installation with waves, improper water puddling, shadowing, improper mortar coverage. Well, if we look at that first picture, that is a prime example of wonderful down lighting. And, if you were to take that light and move it another 2 or 3 feet out from that wall, I don't know if it would look a whole heck of a lot better, but it would probably look somewhat better than it does now. But that's a prime example of the effects of lippage on a vertical surface, to where that light is showing those shadows. If we go to the bottom right-hand corner where you see the penny there, you can see some lippage there. And in the TCNA handbook, there are requirements for the installer that, depending on your grout joint size, depending on your tile size, and a few other math equations in there, it can tell you the allowable amount of lippage, which we want to choose or install with as little to no lippage as possible, right? And that's hence you've got a whole new market on these types of clip spacers, or some people call them leveling spacers, that work and help eliminate that lippage. But lippage is also something you want to look at, in the sense that lippage could cause problems with people walking, tripping on it. And next thing you know, you find yourself in court because you did an installation that somebody tripped over because the lippage is excessive, and now somebody's hurt. So lippage can affect from either shadow lighting or either lighting from a floor. Some days where that penny is, you may not be able to see that lippage too well, and then by mid-afternoon, if the sun's coming across it, you might see it even more. But if you look at the top right-hand picture, that's a great picture of puddling. So that floor is not flat, or at least it wasn't installed flat. You've got an area where it's collecting water, and that can be a slip hazard that can cause other problems to the grout, to the mortar underneath it. Once again, we are looking for that flat floor. Then we got improper mortar coverage. The wonderful, beautiful spot bond. I don't even know why they troweled the wall on this picture, because really it was just the spot bonds that were touching there. But as we all know, spot bonding is not acceptable with mortars. Some manufacturers have products that are made for it. Very few of us do. But this is an example of spot bonding where they were probably trying to get that tile to where it needed to be flat with the other pieces. And keeping that in mind, whenever I do my trainings, if you've ever been to one of my trainings across the states, when I'm talking to contractors, the question I always ask is, who likes to install tile on a flat floor? Raise your hand. And I'll tell you, if I'm teaching 30 people that day, 30 people are raising their hand. A flat floor makes an installation, especially with larger tiles, so much easier, so much easier. So again, this goes back to the ANSI 108.1, goes to the TCNA requirements for surface flatness. These are all things to look out for. So now we're moving into, okay, we've talked about some of the issues that are out there. How do we fix those? And we'll go through these one by one. But we're going to talk about self-levelers, patching compounds, and mortar beds. Now, self-leveler is pretty much in the name. It's a flowable hydraulic cement compound that is made to, as like water, seek its own level. Sometimes you got to push it around, you got to put it where you want it, but it kind of carries that concept. It's going to give me a level floor, or a floor that is going to meet those tolerances required. Then we got patching compounds. Patching compounds traditionally are going to be where maybe we're just fixing a bird bath area. Patching compounds are either add with water, add a latex to it, but they're trowelable products that you push into the area that you want. You flatten it out. Maybe you run a screed over the top of it, and you work your way to getting that flat required surface. And then mortar beds. Now, that's a terminology Jim and I were actually talking before the presentation. Different words, different names for it. Mortar beds is what the TCNA handbook uses most of the time. I've always referred to them as mud beds, or if I'm going on a wall, scratch and brown, or a float. So there's all kinds of different terminologies that kind of equal to the same thing. And you can see that in the right-hand picture, where a mud bed is going to give you a bit more work. It's a little, I don't want to say difficult to use, but it's a situation where you're really working it. You're working it into place, and you're forming it and making it what you want it to be. So let's move on and let's talk about each one by itself. So when we talk about self-levelers, as a manufacturer, this is probably one of the products that we have that has the most chemicals to it. If you were to look at the recipe for this versus a traditional thin set or LHT mortar or patching compound, this is probably going to have the most products to it. And why is that? Because we're trying to make a product that is mixed up very thin. Let's use pancake batter as a kind of an idea to picture it. So it's thin. We want it to be fluid. We want it to flow. We want it to self-heal for a little while until it starts to dry. But then at the end of it, we want it to be able to go the thickness that manufacturer's product will go to, but also too is we want it to dry hard. We want it to meet those PSI strengths, so that way we've got a long-lasting floor. So self-levelers are a very, on the manufacturing side, a very tricky product to make because of all the chemicals and products and raw materials that go into making these products. But they're also, in my opinion, one of the easiest products to use. I mean, heck, you follow the directions on it, you mix it with appropriate RPMs, with appropriate paddle, appropriate amount of water, and you prime the floor, you pour it out, you push it around, break the tension on the surface, and you walk away. Used properly, you will have a flat or almost perfectly level floor in that instance. So self-levelers are fantastic products. We make one, Merkrete's underlay SLU. Our particular mortar or SLU can go up to 3/4 of an inch. Some products and manufacturers have products out there that can go up to 2 or 3 inches. Some of them may not state it, but they may state in the directions that a aggregate or a product like pea gravel can be added to that product, following the correct directions to increase the height or how much or how thick we can go with that product. So self-levelers, great products. But when we look at self-levelers and we break these down, and we're going to kind of go through a couple of pages here of methods. This is my particular graphic that I've always used. Is we've got a concrete substrate, we've got a primer, self-leveler, and then we've got fracture guard there, which is the Merkrete crack isolation membrane, and we got thin set and grout. Now, as you see here, one of the most important things on this particular slide is primer. And as a manufacturer, when we look at how much self-leveler per year we've manufactured, and then we go in and try to compare how much primer we've manufactured, for some reason, they never equal the right amounts, to where it's a lot less primer going out with the self-levelers. And our question is are people really using primers? Well, there's a couple of reasons you want to use a primer with a self-leveler. And one is for the warranty, most importantly. Second is it helps in a few different ways. One being it creates a chemical bond between the primer and the substrate. The other is it helps that product flow easier. If you were to pour self-leveler out on a floor that does not have a primer, it will flow, but you might have to push it around a little bit more. But if you've got a primer down on that floor and you push it out, you'll probably get a little bit better coverage. It's a little easier to move. It's a little more flow to it. And then the other is self-levelers are designed to dry at certain speeds, at certain temperatures. If we don't have a primer there, we've got now an absorption. That moisture from the self-leveler is now absorbing into the substrate, and then it's evaporating out of the top. We want it to evaporate from the top, so that way that self-leveler is drying at the pace that it was manufactured or by that manufacturer's pace. So primers are extremely important. If you're using a self-leveler, if that manufacturer requires it, use the primer. Most importantly, you want that warranty. Then on the slide too, you see the fracture guard, the crack isolation membrane. We are a manufacturer of crack isolation membranes along with everything else in the industry, but crack isolation membrane, we'll talk about at the very end of this, but it's an important step in this. But one of the things I wanted to show on this slide, and you'll see it in the methods that we're going to talk about here in a moment, is you notice that crack isolation membrane is not underneath the self-leveler. It's on top of the self-leveler. We want whatever membrane you're using, we want it as close to the tile installation as possible. So that way, if there is movement or an in-plane crack that happens in the concrete, it'll probably more than likely telegraph to the self-leveler, and then it's going to stop at that crack isolation membrane point. And that's where we want it. We don't want to have it between the self-leveler and the concrete. We want to encapsulate or keep everything below as close to the tile as possible, safe from cracks. So now when we look at methods, this is method 205A, F205A. So basically, we're looking at an above ground concrete cementitious self-leveling underlayment method. This is directly out of the TCNA handbook. What we've done, and we have these available, is we've taken and kind of added our products into this area when you see Merkrete product assembly. But more importantly, when you look at this method here, what do we see? We kind of see what I just showed you in the prior slide. We see a concrete above grade for this particular method, a primer, cementitious self-leveling underlayment, optional membrane, that's where that crack isolation membrane could go into. And we've got our bond coat, which is going to be our mortar, then our grout and tile. So it kind of repeats what we just showed you. But what I really want to show you is I pulled it out of the TCNA handbook from this method, is if you look at that, for slab on ground construction where no bending stresses occur and floor flatness is critical, such as when tiles with any edge longer than 15 inches are specified, or where accessibility is a concern. So once again, within that method, it's telling you that this is a method for flatness. You have to have that flatness with tiles with any edge longer than 15 inches. So again, even though there's a picture within that method, there's all these other little subcategories or paragraphs within it that tell you what the requirements are or what that substrate is going to provide you. So now when we look at it here, this is going to be a self-leveler over 19.2 center. So this is F or M, MKF 185. It's joist 19.2 on center, plywood subfloor, cementitious self-leveling underlayment, and ceramic tile. So when you look at this, it's very similar to what we just looked at, except for our substrate changed. Our substrate went over from concrete to now wood. And we've got showing here our joist spacing 19.2 on center. We've got our 2 layers of plywood. We've got our gap showing in there that's required. And then from that point on, when you look up, one of the things you're going to see on here, you're going to see primer, but the next in line, you're going to see metal lath. When you're going over a wood substrate, you're adding metal lath to a self-leveler, you're now giving that self-leveler more strength and integrity for that expansion, contraction, or maybe a little bit of deflection that's going to be in that substrate. So that metal lath, unless the manufacturer self-leveler says you don't need it, metal lath is imperative to this type of installation to really help mechanically hold that self-leveler down. You've got the primer there, but also to give some integrity to that self-leveler for strength. Then you see that we've got the optional membrane. Once again, it's going to be right below your mortar, your bond coat, your tile and grout. But again, over on the left-hand side, this is what I pulled off of this particular method. It was either under recommended uses or by other trades, but it's for tiles with at least one edge, 15 inches length or longer. So when you're moving into that large format tiles, whether it be a plank tile or a thin gauge porcelain tile, what we're looking at is that floor, if you use this method done right, you're looking at a variation of 1/8 inch and 10, and so less than, and from required plane. So again, these methods are to show you that there are options for those installations. So that's why I always say when you go into that installation, you need to take a look at it. What am I dealing with and what am I going to have to do? And I'm sure a lot of you installers that are here today are putting all these into your bids when you look at those floors and saying, this is what I need to do. But that TCNA handbook is a wealth of knowledge. Okay, so that was self-levelers. So let's now talk about patching compounds. Patching compounds are really again, I've been in this business for over 30 years. When I first started in the industry, really patching compounds were only really used for the resilient side of the business, for your vinyls and the soft goods part of it. But now that tiles have started getting larger and larger, you're starting to see more manufacturers like Merkrete come out with products that are for patching or for just fixing those low spots in those floors. If you look at this particular product here, the Pro Patch Plus, it's one of our premier products. This is a patching compound that you can actually just add water to for over clean concrete substrates, and it's a screedable product. We have people taking this and they'll look at their floor, that substrate, and say, hey, you know what, there's some pools in it or bird baths or whatever you want to call these in that floor. I don't need to raise the floor. I just need to fill in these low areas to bring it up to that tolerance that we're looking for. You mix this product up with water, take a screed, drag it across the floor, walk away, let it dry, and now you're installing on top of this. So with the larger tiles that we're now seeing in the industry, as we've talked about earlier in this presentation, that tolerance, that flatness that we're trying to achieve is very important. So we're trying to give, as manufacturers, give you these products that make your job easier and quicker to be able to get and start putting that tile down. Because again, we'll say it, we're going to talk about it later. What is the one product most people use that you really shouldn't be using when you got that little low spot or bird bath in your floor? They're using their mortar, and mortars are not designed to do that. thin sets, or LHT mortars. They're not designed to patch floors. They're bonded. They're there for two reasons and two reasons only. And that is to bond a tile, or bond to the tile and bond to the substrate. That's it. So patching compounds. We talked about the recipe for self-levelers. Patching compounds are pretty high up there in the amount of products or raw materials that we're putting in these, but not nearly what they are with self-levelers. These products can be used for embossing, for smoothing, ramping, filling small voids, all of those. So they're unique products, and we look at it on the sales side of our business as a manufacturer that nowadays every tile installer out there should have some type of patching compound in the back of his vehicle, because he doesn't know what he's going to get when he walks in on that floor unless he's already been there. So patching compounds are a great way to fix and fill those little bird baths. So again, like earlier on the SLU, I've got another little graphic here that I'm showing you guys. Is concrete substrate. We've got a little kind of, let's say, call it our little bird bath. We've got a patching compound in there. On top of that patching compound, we've got a fracture guard, crack isolation membrane. We've got thin set, tile, and grout. So it's pretty basic. One of the things that you're going to see, or that's kind of strange in this, is we'll go ahead and go to this page here. Is where in this do you see a patching compound? We see concrete, we see optional membrane, we see bond coat, grout, tile, but we don't see an area for patching. I don't believe, and I think I'm pretty correct in this, that there is a method that involves patching compounds. It's either self-levelers, mud beds, cementitious board units, or backer units, uncoupling mats, and all kinds of other things. But there's not one for patching compounds. And the reason I think behind that is because when you read into these, and for example, over on the left-hand side and right-hand side, these are both taken out of this particular method, F113A, is that floor for shorter tiles, we're looking for a 1/4 inch and 10. For large tiles, we're looking at 1/8 and 10. So they're telling you that concrete is supplied to you by the general contractor or the home or whatever job that you're working on. And then now you're going to go in and you're going to do this method over an on-ground concrete. Well, if it looks like any of those pictures were earlier where we had that straight edge or that level on it, we've got the concrete, but now we need to bring it into tolerances to meet those requirements for floor flatness. How do we do that? Well, there's self-levelers we talked about, but maybe we don't need to raise the floor. Self-levelers, typically you're going to use that over the entire floor to raise it. A patching compound like the Pro Patch Plus is you're going to use that product to just work in that little small area, or maybe those bird baths where, like I said, a lot of guys are taking this particular product and screeding it across the floor, filling in the low spots, walking away, and coming back, installing on it once it's been dry. So again, all of these methods have one common theme to them, is no matter if it's a self-leveler or a mud bed or whatever the case it may be, they're telling you that floor needs to meet this flatness when it comes to putting your tile on top of it. So now we're going to look at this on a vertical surface. This is pretty much a standard one here, and it's a W244, is wood or metal studs, optional vapor retarder depending on where that wall is within your home, cement backer board, optional waterproofing membrane, once again depending on where that job is, your bond coat and grout. But we look at these and say, okay, what if the studs or the walls aren't plumb, or what if one stud's sticking out further than the other? Some installers will address that by putting furring strips behind the cement board before they put it up, and some guys won't, and they'll come back with a patching compound. We've got ours, Pro Patch AL1, where it's a thicker consistency, where you're able to go in and fix that bird bath that's on a vertical surface. So those low spots, very important, especially when you get into the thin gauge porcelain panels. We want to make sure when those are being installed, those large tiles, that every piece of that, it doesn't change when it comes to coverage, that we're looking for, depending on the application, 80 or 95% better coverage. So how do we achieve that? By having that flat surface. We as manufacturers are giving you those products, manufacturing those products to be able to work and give that flat surface to be able to have the best insulation possible. So now let's talk about mud beds. Mud beds or mortar beds, gosh, I'm not going to read the whole thing, but basically when you look at this, in my last parentheses in that sentence is 4-to-1 mix. Some guys go to 3-to-1 mix. If you're not familiar with what that is, typically that's going to be for this one, 4 scoops of sand to 1 scoop of cement. That's your typical deck mud, floor mud product. We manufacture our Underlay C, which is actually a polymer modified mud bed that can go up to 3 inches. But a typical mud bed is going to be a guy out there with sand, cement. They're mixing it on their own to a dry pack consistency. It's not wet. It's not nearly as fluid, or not even fluid at all, as the Pro Patch Plus in our products. But when you've got mud beds, these are typically products that you're forming. We see these used a lot in shower pans when we're pitching to drain. We see them used a lot on exterior decks. When, once again, they're pitching from drain, or pitching from, let's say it's a home attached to a deck. But these are used quite often, this type of method that's used quite often. But you can also work these up where you can get some extremely flat floors with these products, and because it really takes some working to it. But again, are we necessarily looking for level, or are we looking for flat? Because if we go to that shower pan and we're pitching to drain, we want it flat, but it sure as heck's not going to be level, because we want that water evacuation, that water to go to where we're pitching it to. So also within these mud beds is going to be fat muds. Fat muds traditionally are going to be that sand to cement mix, and there might be a cup or two of lime that we're putting into it, and that makes it a little bit stickier. So when we're going on vertical surfaces, and that's really the difference between a fat mud and a deck mud. So talking about these, when we're looking at the kind of this graphic here that we're showing to you guys, is we've got a concrete substrate, and excuse my dogs, it's the perils of working from home. We've got a concrete substrate that we're putting a mortar bed on top of. So that's going to be our 3-to-1 mix or 4-to-1 mix, or mud bed, whatever term you'd like to use. And then once again, we've got a crack isolation membrane, then we've got our mortar, our thin set, and then our tile and grout. Pretty simple in that installation, but what we're really looking at is typically mud beds are going to be going with a thicker application where we may need to build that up. To give you an example, before I moved out to Chicago, when I was on the West Coast, I did a kind of a remodel job for a buddy that was working on his home that enclosed his patio, that pitched from the home. It wasn't a too big of an area, and he enclosed it, but he didn't want to step down. He wanted it to be level because he was going to put a pool table in there. So we actually floated that entire area, and it went from, gosh, almost from about a 1 inch all the way up to 3 inch in thickness, and so we're able to meet and level out that application when we met at that existing slab. So again, mud beds are used all the time. Great way to make a floor extremely flat because you're working it into place. Now, when we look at methods here, is we've got method F112, and this is going to be an on-ground or above-ground concrete bonded mortar bed ceramic tile. So when you look at the cutaway of this, we've got concrete, then we've got our mortar bed bond coat, and then our mud bed, mortar bed, 3/4 inch to 2 inches for this particular application. Some applications, if you're going over a wood substrate, they might require some type of metal running through that, whether it be metal lath or I don't want to say chicken wire because that's really not acceptable in our industry, but a metal lath going through there. Optional membrane, once again, closest to that tile installation, and then our bond coat, our grout, and ceramic tile. And again, I pulled this off of this method for areas where floor flatness is critical, such as where tiles with any edge longer than 15 inches are specified, or where accessibility is a concern. So once again, it's referring to those large tiles because that's really where the industry has gone in that. So we want that flat floor, and a mud bed is going to give you that flat floor if done properly. Now, when we look at it on a vertical surface, it's kind of the same thing, but we've got a scratch coat. We've got our cleavage membrane scratch coat, our mud bed or float is what I typically call it. So you got a scratch and brown, optional membrane, our bond coat, tile and grout. We're seeing these being done more and more. You're starting to see, because of the size of the tile that's now being manufactured, you're starting to see a lot of groups that are putting on events. For example, we've got an event coming up next week in Idaho. There's also an NTCNA event going on in Columbus. Ohio the next following week that is really addressing using mud beds. So you're starting to see this application kind of come back into the industry, and it's due to the size of the tiles. We need flat substrates. So how are we going to get a flat substrate? We're going to create it ourselves. And that's really what this comes down to. We're creating a substrate to do that flat or do that best long lasting installation we can do. So when it comes to do's and don'ts, when we're talking about do's and don'ts, we look at these and go, I always refer to this as like going to a self-help seminar where we go through it going, I've heard that before, but yet do we really practice it or do we put it into our life? These are things in there that I've kind of put up that I've seen over the years, but in our do's and don'ts. So when it comes to do's, we do want to check that substrate to make sure it meets that required TCNA tolerance for the tile being installed. We want to make sure not only does it meet that tolerance, but again, and it's in another bullet point here, is that we want it to meet the ANSI A108.1 as well. We do want to make sure on a wood or non-back substrates, that floor meets the deflection values of L over 360 prior to substrate. If you're not familiar with L over 360, look it up. I'm not going to get into the math equation of it, but that's basically how we currently measure deflection. So when you're talking about ceramic tiles and porcelains, we're requiring a L over 360 deflection, or no more than L over 360. And then we're looking at natural stones, it's L over 720. So it's even more stringent. Use appropriate products for flattening and smoothing. Don't use a mortar. And I think I say that in here somewhere, in my don'ts, but use the appropriate products, self-levelers, patching compounds, level coats, whatever it is that's provided by a manufacturer that is made to be used that way. And the reason I'm saying it that way is because thin sets or LHT mortars are not made to do that. We want to make sure that substrate meets those ANSI 108.1 designations. We want to use a primer self-levelers. I can't hit that enough because as a manufacturer, and I'm sure if there was other manufacturers on this with us, they would agree that you see a lot more self-leveler going out than we do primers. So primers are imperative. Follow product manufacturer's instructions. Man, that's a big one too. Use the appropriate mixing paddle. A lot of self-levelers require egg beaters. Use the appropriate amount of water. Measure the water. If you use too much or too little water, that product's not going to perform at the specs that manufacturer made it to perform at. If you add too much water, you're going to thin it out. You could end up with shrinkage cracks. Your compression strengths are going to go down, and it can actually be the same thing with too little water. So measure your water. If it requires a certain RPM for mixing, follow those instructions. You don't want to entrap too much air into those products. So again, follow manufacturer's instructions. When it comes to don'ts, don't assume the builder supplied you with a perfect substrate. I think we can all pretty much agree to that I've yet to see a perfect substrate out there when I walk in on a job. Don't think that CBUs, cementitious backer units, or the like will fix deflection. Over my years, I still talk to a lot of contractors out there that say, hey, if I put this 1/4 inch XYZ board down on the floor, it's going to help with the deflection. My response to that is typically, well, call that manufacturer and ask them if they warranty for deflection. Most cases, they don't. If I can take a cement backer board, bend it over my knee and break it, it has no structural integrity to it. So those products are made to give you a bondable surface, not fix deflection in a wood substrate. Use adhesive mortars for filling voids in the substrate. Don't do that. That is a #1 thing that we see a lot done out there, even like that spot bonding picture that we saw out there. In a sense, they spot bonded, but they were using that mortar to adjust that tile far deeper or more than it needed to be. Don't guess water to product ratios. That's when I was talking about the manufacturer's instructions. We see a lot of people guessing out there. And then don't bond to unsuitable substrates. That's a big one. We're starting to see a lot of manufacturers, home builders. I'll give you an example. We've dealt with some home builders that they're putting a wood subfloor down over their wood subfloor, and it says that it meets the requirements for ceramic tile, but there's one problem with it. It is yellow pine. It is not a hardwood. Yellow pine is not a product we want to bond to. So make sure that we're going over a suitable substrate in those applications. So like I said earlier, we're going to hit real quick here on crack isolation membranes. You know, what type of crack isolation, not really what type, we're not going to dig into too deep, but you know, when we talk about crack isolation membranes, I always like to have pictures here. Crack isolation membrane, the reason, again, I'm bringing it up is because in all those methods, it showed a optional membrane. In my world, it shouldn't be optional. How would you, I'm sure we've all seen these types of floors in these pictures. You got a Saltillo paver over here, very soft material, travertine in the middle there that's got a crack through it, and then a almost looks like a terrazzo there with a crack running through it. But how many of it we've seen those? What if we can prevent those? Crack isolation membranes are insurance, is really what they are. We work with a lot of new home construction, new home builders, where they're using our products on these new home builds when there's no cracks present in those floors. But it's an insurance that we want to give them, that if there's an in-plane crack less than 1/8 inch or less that happens on that floor, we're going to stop it from telegraphing through and end up having a floor that looks like this. When I say it's an insurance, I always like to use this as a kind of a hypothetical situation. If I've got a 10-foot by 10-foot room, it's 100 square feet, and we want to put jade green marble down, and I'm just throwing a price out there to make my math easy because my math isn't that great, at $10 a square foot. So just in stone, we got, you know, 10 by 10, 100 square feet times $10, we got $1,000 just in marble. Now you got materials, mortars and grouts and everything, and then you got your labor. Now I might get, you know, laughed at here one way or the other, depending on where you're at in the United States. Let's say the installer is going to charge them $10 a foot to put it down. So now we've got another $1,000 invested into this floor. So there's no crack in the floor when he did the installation, but let's say a year or two down the floor that something happens, home settling, something cases where a crack appears, stress crack, shrinkage crack, and now it telegraphs through that floor. If we go through that now and we need to repair that because it's unsightly, looks like one of these pictures, are we just taking up the tiles that are broken and painting a membrane or putting some type of membrane down on that floor? No, we're not. If you look in the TCNA handbook, there is actually a method for partial coverage. And when we do a partial coverage, when you dig into that, it tells you that you're now covering 1.5 times the size of the tile that's being installed on each side of that crack. So what that means is it's a 12 by 12 tile. You're talking now 18 inches each side of that crack. So in a sense, you're ripping up that entire floor just to chase a crack. So we always recommend put it in there as an insurance so you can pretty much guarantee to your homeowners that if there's an in-plane crack under 1/8 inch, that floor is not going to crack in the future. It's just that insurance for not only you as an installer, but also for the homeowner. So that way they've got a beautiful floor that lasts forever. Now, crack isolation membranes, when we're talking about substrates, slab on grade, we're talking about moisture issues, hydrostatic pressure, efflorescence, type of concrete pour. Is it a post-tension conventional? And then again, curing compounds. We see a lot of curing compounds when we come to those above ground floors or above ground concrete pours. Curing compounds are bond breakers, big time bond breakers. Now, when we're talking about above grade floors, with wood, we're talking about deflection. That's our biggest thing that we see out there. When we talk about post-tension slabs, again, above grade floors, hydration, cracking, again, curing compounds. And then we got gypsums. Again, like I said, Gypcrete, we've got Etranogite. These are very difficult surfaces to bond to, but there's also things to take into consideration of. So that pretty much covers it with everything that we've got. So if there's any questions that y'all may have, I'm here to answer them. Again, my email was at the very beginning. If you wrote it down, you feel free to email me at any time. But Jim, let's take some questions.
Wow, I have to tell you, it was an outstanding presentation, Brett. It was loaded with a ton of excellent information for all tile professionals, and this is seconded by many comments on our question screen here. So great job. But we do have some questions. So let's start off with a correction for us. All right. So Brett, Scott Carruthers from CTEF said that it should be ANSI A108.01. I think you said 0.1. And he's saying it should be okay. 0.01. Okay. 0.01. Yep. Okay. Just for everybody, so we're always correct. It's great to have with these professionals, but that should be A108.01.
I'm writing it down right now.
Perfect.
Thank you, Scott.
And thank you, Scott, for that. That's great. I appreciate it. Here's one, and it says, and I'm gonna hopefully you understand this because I've read it a couple times. I just want to make sure. So if my memory serves me correctly, we used mud to fill in bird baths on a vertical surface at the NTCA workshop substrate prep for large format tile. You mentioned a patching compound is required. Can you explain the discrepancy? And could I ask, I know our training director, Mark Heinlein's on here, and maybe he can clarify that here if possible. But if you wouldn't mind just going over that again, that'd be great, Brett.
I don't think I said required. Some areas where if you're using a mud to fix let's for example, if we've got a wall that is cementitious board, so there's a CBU up on that wall, and let's say there is a bird bath on that wall, and we want to be able to fill in that bird bath and to be able to have that flat surface. And I know we did something like this when we were out in South Carolina working with Scott for training with my group. And if you were to just do a mud bed that is cement and sand, first and foremost, it's not going to stick. It'll just fall right off the wall. A patching compound has polymers in it for the most part, and if not, you're adding polymers by adding a latex or an acrylic to it. So that way it creates that stick to it. So that way it will stick to that vertical surface, and you can work with it and trowel it or screed it into place where you need it to be. I hope I'm answering that question right.
Thanks, Brett. And I actually believe in that situation they might have NTCA may have called that a mud, but it definitely had polymers and was used to live, and it had to stick on it. So I hope, Alice, I hope that answered your question. Thank you. I want to just jump in real quickly with something. So Brett said something that's really, really important, and I don't want people to miss this, but he talked about make sure you follow manufacturers' recommendations and their instructions on how to use their product. And I just want to make sure that you understand all manufacturers' recommendations supersede TCNA handbook methods and any of their recommendations. You always follow the manufacturer's recommendations. Number one.
Absolutely.
All right. So I just wanted to go through that because I listen to these and sometimes they can just be glazed over really fast, and I don't want anyone to miss that. So definitely. Hey, Mark Heinlein jumped in here, and Mark Heinlein is the NTCA trainer and training director, and he said he's looking forward to working with you, Merkrete, for their mortar bed, thick bed regional training coming up in Columbus, Ohio on August 26th. He wants everyone to know that attendee capacity is limited and there are a few spaces left. If you want to contact Mark at tile-assn.com or call me or contact me for course and registration information. These are a full day long and they're free. I just want to make sure everybody understands that. All right, let's see here. Here we have another question. How does one gauge the RPMs based on the drill used? I have always wondered and never find it in manuals for drills. That's a good one. I love it.
Yeah,
I love it.
That is a good one. You know what? There are, to answer that question without answer the question, but I'm going to leave it open. There are manufacturers that within the tool bit within our business, tool manufacturers, I don't want to name any of those that have drills that have adjustable RPMs, and those are probably going to be typically the best out there. If some of you guys in the comments, if everybody can see those, if you guys have those and you want to mention those, you're more than welcome to. I, as a manufacturer, don't want to mention anybody's particular name because I'm thinking of some right off the top of my head, but there are drills out there that have the adjustable RPMs. Otherwise, man, if you're using a DeWalt drill and it doesn't tell you in the directions what the RPMs are for it, then there's just really no way to know. So
yeah. And Brett, many of those drill manufacturers in our industry have two settings, and one is for self levels and one is for thin sets, and others have variable speeds. So check out those manufacturers, and all of them support NTCA and our programs and what we do in our industry. So check them out, and they'll be able to assist you on that for sure.
Yeah, absolutely. Now, you know what, Jim, before we take a question, there's something I want to address here that I did not in my little graphic that I put up on the screen. Is at the very bottom of that, it says, note, movement joints must carry through entire installation system. I kind of forgot to bring that up. It said it, and I hope everybody saw that on all of my little graphics that I made. Just to reiterate to that, have to follow EJ 171 out of the methods for the TCNA handbook when it comes to expansion joints, soft joints, movement joints. They have to carry through the entire installation. Crack isolation membranes.
Yep, one more time. NTCA.
NTCNA.
The TCNA handbook. Method EJ 171.
Oh, I'm sorry. TCNA handbook.
TCNA handbook.
EJ 171. These methods are so important, and as a manufacturer that goes out on as a person that goes out on a lot of claims, we see where there's saw cuts, expansion joints, lack of movement joints that are not that they bridge over. Self levelers, mud beds, even when they have a metal lath in them over wood, which I don't know why you would be doing that, but is these types of EJ 171 movement joints have to carry through the installation.
Perfect. I love it. So good to give this information and make sure it's clear. All right, here's another one from Alice. How does an installer decide on the quality of the substrate for a job where a demo of an existing installation is required?
Well, gosh, there's ways to look at it. If there's a concrete substrate, and I'm just going to kind of go off of a whim here. If it's a concrete substrate, and let's say you're pulling up an old vinyl that happens to be over an old VCT that happens to be down on that ground, the concrete's in good shape. You pull up the vinyl, you see that the concrete's in good shape, but you might see some glue residue left behind. The best way to approach that is to either shot blast or grind that residue away, opening the pores and giving you a good substrate to bond to. Let's say if that's not an option, depending on what that glue is made up of, I know that we have it, other manufacturers have it. We have some products out there that they're kind of multi-purpose primers that can go over that will bond these adverse, I use that word, adverse substrates. In some cases, I would say, you know what, our Pro Patch Plus or AL1, you can add a latex to the Pro Patch Plus, and I'm going to use old cutback residue that's on it. We want you to scrape down as much as possible those ridges. It's going to leave a residue behind. Pro Patch Plus mixed with the latex will actually encapsulate over the top of it, enable you to install tile directly on top of it. So it just depends on that situation. If it's a wood substrate, you pull up a vinyl and there's glue there, really, I think in the reference manual from NTCNA, it's going to tell you, and I agree with it, that you need to replace that subfloor or put another layer on top of it.
Very good. Very, very good. I hope that answers your question, Alice. If not, send something quickly in and we'll try to get to that. Our next question is, relative to the do's and don'ts slide, I am understanding that the tile industry installers, contractors are not responsible for or trained in the L/360 deflection values. Please explain this.
Oh man, no, you know what? If you're in one of my trainings and we're talking about wood substrates, I always bring up L/360, and I kind of give an example of it. It's in inches, so it's length divided by 360 inches, and there's a weight put down onto that floor. In a sense, imagine taking a string, putting it across that floor from point to point, and you measure, at certain integrals, the distance from that string down to that floor. Then you add a dead load or a load of, it's either 250 or 300 pounds. It's been a long time since I've looked at it. You're adding a load to it, and then you're seeing if that floor deflects down or moves down from it. Then you go back and measure your string. If it has moved, then you've got a deflection issue. I'm going to give you the simple term in it, and what I always tell everybody is, if you have 16 on center, which is kind of a standard joist spacing, and you've got, whether it be 3/4 inch plywood on it, or you got 2 layers equaling 1 1/8 is what we prefer. that deflection between joists, that's 16 on center, by doing the math with the L over 360 is less than a 16th inch deflection in that floor. I always say that we can make mortar bend, we can make grout bend, but we cannot make tile bend. And if that floor has any deflection to it, whether it be between joists or the joists themselves, and I'll give you another example here, is that tile is going to pop or crack. Now, another consideration too with this is we see a lot of home remodels where people don't realize that they have a standard home, track home that was built, and then next thing you know, they won the lottery and they're going to redo their kitchen. So they rip out all the cabinets, they put in new cabinets, they put granite countertops on top, they go out and buy a Sub-Zero refrigerator that's inset that looks like the cabinets, they buy a Viking stove, all these new things that home was not designed for. These are all what we call dead loads. And what those affect your joist deflections. So with that being said, is just by remodeling the kitchen, if those joists weren't designed to handle that weight for that original home construction, that could be a problem in there on its own. As a contractor, are you responsible for that? You're responsible for that floor from the day you take that floor over on it. There's actually a beautiful paragraph or beautiful page in the TCNA handbook that talks about deflection and the responsibility of whose responsibility is it. But once you do something to that floor, let's say you go underneath it and block it, or you add layers of plywood to it, you've accepted that floor. Now it is your responsibility. Does that make sense?
Yeah, and it's really good that you mentioned TCNA handbook again, and you can look in there. And I know at the back of the book there's like a table of contents that explains those kind of things, and you can look up L over 360 and it will give you more of a definition, and hopefully that you'll understand that.
Yeah, so, I might have been off by a few numbers. It's been a long time since I've looked at
no, you have the right idea, and I hope that does answer it. So I think your real answer to this is you're not responsible unless you do something to it, right?
Exactly.
Yeah, great. All right, here's another one. We use a variety of materials at our class. All right, this is again NTCA's training classes. We use rapid setting patch materials and thick bed materials designed for walls. And I guess what Mark is saying is that during the demonstration we did, it wasn't just a mud that was put up there. It was actually a patch material that was being used. So
yep.
Just so everyone understands that. All right, let's see. We got people saying thank you. We've got, here's one. We recently completed a project where the floor tile is in compliance with the flatness requirements. However, the owner and architect are performing water flood tests on the floor and noting that the puddles make our floor out of tolerance. We are within 1/4 inch and 10 feet. Actually, we are below 1/8 inch and 10 feet, but the water still does puddle in bird baths. How can we convince the owner and architect that A, the water test should not be used in this instance, or B, the water puddling does not mean the floor is not sufficiently flat?
That comes down to, that's actually a great question. That comes down to this blue book that I'm holding in my hand. And it is the handbook. Yeah, I know. But it's the TCNA handbook for ceramic.
I'm going to hold it up.
There you go. Stone tile installations. This handbook is your battle. I live, breathe, we as a manufacturer, me as a person, live and breathe by this handbook. This handbook is what, as an installer or installation company, is what backs you up. When you look at this, there's whole sections in here regarding flatness and tolerances and all of that. So that when you put this in front of that installer saying, look, I gave you an installation, my tile installation. I don't have the lippage. I don't have, I've got a flat floor that meets the industry requirements tolerances in that. Regardless, putting water on top of it is not a method of testing that I know of. But it's one of those things where it's using this handbook to sell them or to show them, look, I did everything as a tile installer to my best abilities, but also to meet the TCNA handbook's guidelines. And I'll tell you, you know, I don't know if it's a joke or not, but you know who buys this book the most in the country? Lawyers. Yep. And so this is your backing. And I always tell contractors too, and I can't say enough about the TCNA handbook, is even if you're, and please don't take offense to this, but I call them one bucketeers. If you're a single contractor or you're a contractor that works for a large firm, is this book in your pocket, in your truck, when you go out to that job and you're trying to explain to that homeowner, look, I understand when we bid the job, we bid it like this, but I'm looking at, now that I've done some tear out, that I'm going to have to do X, Y, Z to that substrate, and that book backs you up on it. They're not think you're there just trying to make an extra buck. You're showing them, look, these are what I ran into. This is what I refer to because I am a tile contractor. This is my governing body, and this is the way that I need to do it.
Okay,
For that
let's see, we got more here. That was good.
With that water test, use the handbook.
Yep, use the handbook. It'll help you through that situation. Let's see here. More thank yous and compliments. You did a great job. Here we go. Here's one of our trainers saying all drills should have an imprinted label attached to the motor that lists the no load speeds, amps, and volts. You should be able to find the speed of it. And let me ask this, Brett, do you, on your back of your bags of setting materials and self levels, do you say what the RPM it should be?
Yeah, for mortars and grouts, it's traditionally no more than 300 RPMs. And then I'm not going to answer the self leveler for my bag because I haven't looked at the back of it, but I know it's not 300.
But they do.
It's not.
They do.
Yeah.
Yeah. And so what we're being told is that you can find it on the label attached to the motor. It should give you that no load speed. So that's good. Does using a liquid applied anti-fracture membrane versus a UCM change the dynamic of the installation in any way other than thickness?
Using a UCM, an uncoupling mat, for those that aren't familiar with the letters there, not necessarily. It depends. There's some uncoupling mats I believe out there that will help with deflection, I think. And I'm saying that if you were to see my face, it's kind of like I think type thing. But most uncoupling mats do not help with deflection. They're wobbling. I mean, we have an uncoupling mat, and it does nothing to help with deflection. It gives you a bond.
Could I just say this? I think the simple answer to this, truthfully, is please reach out to the manufacturer of your uncoupling mat and your liquid applied anti-fracture membrane and ask that question of them, because each manufacturer might have a different answer, and it's really important that you get that information from them. Go to your distributor; they'll give you they'll give you the number of a technical line for that manufacturer. It should be on the packaging. So yeah, I think that's really important.
Yeah, I can tell you with my fracture guard, it's a liquid applied crack isolation membrane that we referred to earlier. It can be used over a wood substrate as a bondable surface, and it will do nothing to meet deflection values. Typically with uncoupling mats, liquid membranes, they're going to tell you that floor has to meet deflection values prior to the installation of these products.
So next question, do the large porcelain panels that are now being used like GPTP, do they have different specs than the 1/8 inch per 10 foot because of their size?
Yes. Yeah, again, that goes back to the manufacturers.
I agree. Always check with your manufacturer when you have these type of questions. Very important.
Yeah, and I said it earlier in the presentation that some manufacturers, you know, we're looking at it as any tile with one edge greater than 15 inches. You know, we want an 1/8 and 10, whether it be vertical or horizontal surface. But I did make a note that some thin gauge porcelain panels manufacturers require an even more stringent flatness.
Last thing is more of a comment here, Brett, and Scott Carruthers from CTF said he's not absolutely certain, but he believes the largest buyer of handbooks are manufacturers. So maybe lawyers are number 2.
Well, that's Scott screwing up my joke.
I want to thank you. Again, it was fantastic, great information. I want to thank everyone that attended today. I think you had you learned a lot. You got a lot of information. Please look forward to our next webinar, which is next Tuesday, August 23rd. An invite will be coming out later this week, and I really appreciate you all taking the time to be here, but I think it's well worth your time. Brett, fantastic. Everybody, thank you. Have a great week, and we will talk soon, okay?
Thank you, Jim.
Bye, everyone.